Hi students, in this video I'll be going through the 2017 O-Level Additional Mathematics Paper 2 question 1. Alright, so let's read the question. So find the value of the constant k for which y equals to e to the power of negative x times x squared is the solution of the equation below. Alright, so the equation is given to us over here. Okay, and they say y equals to e to the power of negative x times x squared is a solution, right? So it means that if we were to sub this y value inside here, it's going to satisfy the equation. Okay, then over here we see that there's a dy dx term as well as a d2y dx squared term. So if y satisfies the equation, if you were to differentiate the equation on top here, the y equals to e to the power of negative x times x squared, you will get dy dx, right? Okay, likewise, dy dx will also satisfy the equation when you sub it in. And the same thing for d2y dx squared when you differentiate the y equation two times, all right? Okay, so that's basically our approach over here. So this is another question that is not the typical type of question. And before you start the question, you must ask yourself, what else is there to be done? Right? So basically, at the start, it's very hard for us to see how this whole equation is going to simplify itself to just a constant k. Okay, but we will still try, okay, our best. Okay, if we differentiate carefully and correctly, when we put it all in and when we simplify everything, we should be able to end up with a constant k. All right. Okay, so I'm going to call this equation 1 over here, and then I'm going to start differentiating. Okay, so the equation given to us is y equals to e to the power of negative x times x squared. Okay, I'm going to call this equation 2. So later equation 2 is going to sub into equation 1. Okay, now we're going to find dy over dx. Okay, so we're going to use the product rule because over here we have two terms multiplied to each other, and both terms are in terms of x, okay, functions of x. Okay, so the product rule goes this way. Okay, leave the first term and differentiate the second term. So we'll just get this plus, okay, now we'll differentiate the first term. Okay, when you differentiate e to the power of negative x, you will get negative e to the power of negative x. Okay, then we leave the second term. Right, we'll just study out a bit. Okay, usually I like to put the x term in front. Okay, so I put it this way. And then over here plus times minus, you'll get minus x squared e to the power of negative x. Okay, so now we have our dy dx, and I'm going to call this equation 3, right? Okay, so we're going to differentiate one more time to get d2y dx squared. Okay, so you may be wondering why I didn't factorize out some common factors in the dy dx, right? Okay, that's because I feel that it's actually easier to differentiate it in this form rather than to factorize it and then have to use a product rule, okay? Okay, but over here, you still need to use product rule individually for each of these terms. Okay, over here, I'm going to just change the color of my marker. Okay, this is the part where you need to be very careful with the differentiation. Okay, in fact, this is the most difficult part of the question. Okay, I'm going to put a bracket over here. Okay, so basically, we are going to differentiate the term on the left, 2x times e to the power negative x, then minus bracket, then differentiate the derivative of the term inside the green bracket, which is x squared times e to the power negative x, right? Okay, so that's basically what we're going to do. Okay, we're going to change the color. I think we're using brown just now. Okay, so over here now we have, let's differentiate 2x times e to the power negative x. So same thing. Okay, different color, but never mind. Okay, leave the 2x. Okay, differentiate the second term e to the power of negative x. So you get negative e to the power negative x. Okay, I'm still differentiating this term, right? Plus, okay, now differentiate the 2x, okay, which will get 2, and then leave the second term. Okay, then minus, okay, so now bring back the green brackets. Okay, so now we're going to differentiate everything inside the green bracket, right? So like this color, right? Okay, so differentiate the inside the green bracket, x squared times e to the power negative x. So leave the first term, differentiate the second term, right? Plus, okay, now differentiate the first term, which is x squared, you get 2x, then leave the second term, right? Okay, so we will get this, right? Let me change it back to green bracket. right? So when you differentiate this, you end up with this, okay? Then when you differentiate this one, you end up with the thing inside the green bracket. Okay, then from here, we're going to start to simplify everything. Okay, so from here, let's just put a negative sign in front. Okay, so just be very careful with this step, alright? Okay, then over here, you have a minus times a minus, so it's going to be a plus, right? Okay, so it's going to be plus x squared e to the power of negative x, then minus times positive, so minus 2x e to the power of negative x. Right, then we're just going to group the like terms together. Okay, so from here you can see that we have three types of terms. Okay, one is the x squared term in front of the e to the power of x, so that's the only term there. Okay, the other one is the negative 2x minus and another negative 2x. Okay, so these two terms can combine together to give you negative 4x e to the power of negative x. Then finally this term with no x in front, just a constant term. Okay, so we'll get this. So we call this equation 4. Okay, so basically what we're going to do is we're going to substitute equation 2, 3, and 4 into equation 1, right? Okay, so that's what we're going to do. Okay, so substitute 2, 3, and 4 into 1, right? Okay, so equation 1 goes e to the power of x bracket d2y dx squared. Okay, so e to the power of x bracket d2y dx squared, so sub this whole thing there. Okay, plus 2 times of dy dx plus y, okay, plus 2 times of dy dx, okay, 2 times of dy dx, okay, so dy dx is over here, on top over here, okay, this one, 2 times of dy dx, so 2x e to the power of negative x minus x squared e to the power of x, right? Okay, then after that, finally plus y. Okay, y is just e to the power of negative x, x squared, right? Then it will be equals to k. Okay, so all we need to do is just simplify everything on the left side very carefully, and we should be able to end up with a constant k. Okay, so let's try. Okay, let's open up all these brackets over here first. Okay, these brackets. Okay, so x squared e to the power of negative x. Okay, then this one, 2 times 2x. Okay, so you get plus 4x e to the power of negative x. Okay, 2 times this, minus 2x squared e to the power of negative x. Then plus, okay, I put the x squared in front, right? Okay. Okay, then let's group the like terms together. Okay, you can see some terms going to cancel off already. For example, this one and this one are going to cancel off, right? Right? Okay, so there'll be no more terms with the x in front, right? Okay, then let's see about the x squared term. The x squared term will also cancel off because this one, okay, maybe I use another color. Okay. All right, let's use a purple. Okay, this one, x squared plus x squared, you get 2x squared, then you minus 2x squared. Okay, so the x squared term is also going to be off. So the only term remaining will be just this 2 times e to the power of negative x. Right, so let's put that in. Okay. Okay, then from here you see you can apply the law of indices, right? Because e to the power of x times e to the power of negative x, you will get e to the power of negative x, then you, because same base you times, right? So you plus x. Okay, so you end up with 2e to the power of 0, which will give you 1. So that's why k is going to be equals to 2. Alright, so this question, the difficult part is to differentiate carefully, okay? So you need to be very well versed with the product rule in this case, and then just be careful with your steps and then try to simplify. Right, so this is the type of question whereby you've got to ask yourself the question that I always ask you to ask, what else can be done? Okay, there's nothing else much to be done except to just differentiate, okay, and then after that substitute inside the equation and then simplify it, right? So though it's a 7-mark question, but doesn't mean that it's going to be a very difficult question, right?